Let's take a look at the Class B AB amplifier, which is in section 10-7 in your text. I'm using figure 1043 as an example, and this is out of the problem sets in the back of the chapter. And I believe this one covers problems 1029 to 1033. First thing that you should notice about this problem set is that this does not use a split supply. It is not plus minus 15 volts. It uses a single supply, which is between 30 volts and ground. There's no problem in doing this, but what you need to remember is that the point between the emitters ends up being halfway between the 30 volts and ground. So this point here, you need to bias it so it's sitting at 15 volts. Likewise, the voltage between the diodes also needs to be at 15 volts. Now there's a resistor in here, R6, which it's a variable resistor, and a variable resistor is put in here so that you can dial this resistor back and forth, and then you can dial in 15 volts at the point between the diodes, and then you will get 15 volts on the output. So the other thing that you need to keep in mind on this particular circuit is that there's a capacitor on the output. Because there's 15 volts on this side of the capacitor and you want 0 volts, the normal voltage that you want on the load is 0, then you need a capacitor to block that 15 volts so that it does not constantly appear across the load. So, and that capacitor needs to be a pretty substantial capacitor, probably in the neighborhood of 1,000 microfarads if you want any kind of low-end response. Likewise, on the input here, if you're going to apply a sine wave to the input here, which is centered on 0 volts, then you need to put a capacitor on the input to block the 0 volts DC from the existing 10.7 volts on the base side. Otherwise, as soon as you connect this in there, you'll short the whole thing to ground. The other thing that you might want to note on this circuit here is you can see that this has a preamp stage in front of the Class B AB driver, and this preamp has a pretty substantial gain. I can see here that the collector resistor is 1K, the emitter resistor is shorted out, which means the gain is highly dependent upon R prime E, and you can't ignore R prime E in doing this example because you'll get a completely wrong answer. So you can't throw out R prime E as a function of estimating. And if I were to estimate the gain on this one, I'm going to figure that R prime E is going to be a couple of ohms. So you're going to have a gain on this circuit in the hundreds. And we're going to look at how to calculate that value right now. So let's zoom this out and grab the DC calculations. So now the DC calculations, they're done pretty much like we always do them. This is the DC calculations for the preamp only. So for the preamp, you need to reduce it to a base drive circuit, so you find VTH and RTH. So I'm multiplying it out here. VTH is 10.8. He says it's 10.7. Then I calculated IB using the standard formula, come up with 65 microamps. I went straight to IE, and I said IE was 9.84 milliamps. And then I did a quick check by finding IC sat at 15 milliamps and VCE off at 30 volts. Draw my load line between those 2 points, plot the Q point. It's about 2/3 of the way up, relatively in the middle of the load line. So that's really enough calculations. I could figure out IC and I could figure out IB, but it doesn't really help me get any further. So I'm going to stop with IE and then just use that calculation in the AC analysis. Let's throw that to the side. Now let's bring in the AC analysis here. So in the AC analysis for the preamp, I've drawn the AC equivalent circuit. Here's R1. on R2, put those in parallel on the base. The emitter goes straight to ground because it's grounded through a capacitor. So we'll do that. And then on the collector here, we have a 1K ohm on the collector. So this is our AC equivalent circuit. Clean this up a little bit so we can see it. That's our AC equivalent circuit. R prime E, I'm using the DC emitter current, call it 2.54 ohms. So Zin is the impedance looking this way, which would be that, and parallel with that, and parallel with that, multiplied by beta. 1, 2, 3, 347 ohms. Z out, you open up the current source, you end up with 1K, and then V out over V in ends up being RC over R prime E, and it's negative because there's a phase shift. So you got a gain of this first preamp stage minus 390. So that takes care of the preamp stage. Let's take a look at this stage in the middle. Now, this one here, you can kind of take a few shortcuts on the calculations because, especially in the DC calculations, because what you've got is you've got this resistor right here, and you're going to use that resistor. We're going to use this resistor to dial in the bias point. So we're going to vary this resistor until this point right here. We're basically going to tune that resistor until this point hits 15 volts. And if this is 15 volts, well, then the base of this transistor is 15.7. And that means that the voltage across this resistor is 14.3. And with those two values, if I know the voltage across this resistor is 14.3 volts, well, then I can figure out what the current through that resistor is, and that is essentially IC and IE. So I don't have to do a whole bunch of calculations. If this is a little bit off, if the 15 volts is a little bit off, well, then you're going to make it on. You're going to dial it in. So you don't really have to do a lot of DC calculations in here. You're going to set it to what you want, and then you can use those values. So the values then are 14.3 volts through a 1K. So IE, let's use an approximation here. This is actually IC. IC is going to be equal to 14.3 over 1K, which is 14.3 milliamps. Now from that, just knowing that, I can probably jump to the AC analysis and figure out what the gain of this circuit is. So let's pull that in. So here's the AC analysis of the second stage of the Class B AB amplifier. So here's the AC analysis. I've drawn the AC equivalent circuit. So R7, R8. R7 is a collector resistor. Here's R8, which is RE. Put those in. I got a 12K here that ends up being RB1. Here's RB2. Put those in the circuit. So the AC values of this guy end up being, so R prime E, 0.025 over 14.3 milliamps. That ends up being 1.75 ohms. Z in then is RB1. It's this resistor in parallel with this resistor in parallel with what's down this path multiplied by beta. So 12K parallel 1K parallel with beta plus 1 times 101.75. That comes out to 871 ohms for Z in. 871. Z out. We stand here and we look back into the circuit, and what impedance do we see? We see RC. So Z out's 1K. AB is V out over V in, which is going to be So AV, there's current going back and forth between these 2 points. So V out's going to be this voltage, which is ICRC, and V in is going to be this voltage, which is that current. So V in is IE times R prime E, RE, plus R prime E. So V out over V in, that's right here. We can approximate, get rid of IC and IE. We'll say those are pretty much the same. This ends up with 1,000 over 101.75. So gain of about minus 9.8. So that's the gain of this guy right here. Minus 9.8. So let's clear some of that off. Let's make this a little bit bigger. Okay, so let's drag these guys in. So stage 1, we said that the AV is minus 390. The Z out is a 1K. Stage 2 on Z in of this one was 347. Stage 2 Z in was 871, and the AV was minus 9.8, and Z out, if I'm looking at just this stage here, Z out was 1K, but I'm going to put a question mark there. So let's now, this is correct. So for this, no problem here with the preamp. That's a capacitor coupled between the preamp stage and the driver. So you would do that as a separate 2-port model. The driver itself, what I usually like to do is I like to do this as a 2-port model. But then what I like to do is I like to think of this as a gain of 1. And I just like to basically put that in with this gain here. So I like to put together these two guys here into one amplifier. The gain of this guy was that divided by 100 plus R prime E, so it was out 9.8. But I like to merge these two amplifiers together, and you need to do that because they are DC coupled. And when you look at Z out here, when you look at Z out coming in here, you actually end up working back through this amplifier here and seeing, if you're doing Z out here, you actually end up working back through this amplifier and including R7, which is the 1K. So if we do these as separate amplifiers, then this guy here is in there twice. It's in there as a Z out of this stage. It's in there as a Z out of this as a stage. And it's in there also included in the Z out when you look back on the push-pull amplifier. And that would result in 2 attenuations. This one is also, if I look at the Z in, here. There's a Z in, which is the load. And then usually on these kind of circuits, we like to throw the load on after. Like to throw the load on after. And you don't want to include these parts twice, because then it looks like a more attenuation than it actually is. So you want to include these parts only once. So Z out would, if we look back through here, basically Z out would be the 1K over beta plus 1 plus R prime E, which in this case now the emitter current here, if this is 14 milliamps of emitter current, then by current mirroring this is also 14.3 milliamps. So if this R prime E was 1.75 ohms, then this one is also 1.75 ohms. So 1K over beta plus 1 I think is something like 26 plus an R prime E of 1.75. You should come out with a Z out of approximately 8 ohms. And we can write that number down in here. And then the load resistor is 100 ohms. So there's your complete Class B AB amplifier after 2 stages. You got a Z in at 347 at the front. And then I've got one stage which has a gain of minus 390, but an attenuation of 1K, a Z out on here of 1K, and a Z in here of 871. So there's an attenuation there. And then we got a gain of minus 9.8 and 8 ohms over 100. So if I put 1 volt on the input here, V out should be 1 volt times minus 390, attenuation 1, times, sorry, gain 1, not attenuation 1, times voltage divider 1, should be 871 over 1.87K, times minus 9.8, times 100 ohms over 108 ohms. Over 108 ohms. That should be, multiply all those numbers out, that should be your end-to-end gain of this 2-port amplifier.